Hello everyone and welcome back again. Today we're going to solve an interesting question on quadratic functions. The question reads, assume the function f of x equals ax squared plus bx plus c, where a, b, and c are members of real numbers. Prove that if x1 equals alpha and x2 equals beta are the roots of f of x, then the sum and product of these roots are given by alpha plus beta equals negative b over a, and alpha times beta equals c over a, respectively. Okay, now let's go ahead and solve this question. I know a lot of people are confused right now, but it's very simple, and this is what we can truly do together. Let's begin from here. The general form of every quadratic equation is given as ax squared plus bx plus c equals 0. This is the general form of every quadratic equation. The number that comes in front of the x squared is our a. Let me show you what I mean. Suppose we have 2x squared minus 3x plus 4 equals 0, right? Now, this number in front of the x squared is our a. The next one that is attached to the x is our b, which is negative 3. This one here is our b, okay? And then the constant term, the term that does not have either an x or anything attached to it, is our c. Have you seen? So in this case, our a is 2, our b is negative 3, and then our c is 4. Okay, so that's how to find a, b, and c. And then when we solve this quadratic equation, because the highest power of x is 2, we are going to arrive at two solutions. For example, if you look at this right here, if you have 2x equals 6, definitely we are going to arrive at just one solution because the highest power of x is 1. But as long as the highest power of x is 2, we are going to arrive at two solutions. Okay, now those solutions that we are going to arrive at, we don't know what they are, but we can call them alpha and beta, right? So we can say one of the roots are the answers, right, that make this equation true. When you solve this equation, you are going to arrive at two answers or at two solutions. Those solutions are what we call roots. So don't get confused whenever they say find the roots. Whenever they say find the roots, they're asking you to find the solutions or the answers that make this equation true. Now, in the same way, if we solve this very equation here by completing the square or using completing the square method, we're going to arrive at two solutions. This equation right now, ax squared plus bx plus c equals 0. Okay? Now, when we solve it by completing the square, we're going to discover or find that x equals negative b. Let me write this properly. Negative b plus or minus the square root of b squared minus 4ac all over 2a. When we solve for x in this general form, we're going to arrive at this very solution, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And this implies that we have two solutions. Look very closely here, or watch very closely. You'll see two solutions. This one here is the first solution, which is for the plus, and this one here is the second solution, which is for the minus. This means that we can separate them. Okay, let's start solving the problem right now. We now have that x1 is equal to negative b plus the square root of b squared minus 4ac all over 2a. And then the second one is x2 is equal to negative b minus, again, b squared minus 4ac all over 2a. Okay, we've separated them. One is a positive and the other is a negative. So this x1 can also be called alpha, while x2 we can also call it beta. Remember from the question, it says if x1 equals alpha and x2 equals beta. So that means that we can call our x1 alpha and then our x2 can also be called beta. So I'm going to write it here. So I will say alpha equals negative b, then plus the square root of b squared minus 4ac all over 2a, and then my beta will be negative b, negative, the square root of b squared minus 4ac all over 2a. So they're actually trying to say that we should prove that the sum of these two roots would give us, for example, we should show that alpha plus beta is equal to negative b over a, and we should also show that alpha times beta equals c over a. Okay, so this is the formula for the sum of roots, and this is the formula for the product of roots. Now, how do we do this now? We can go ahead and add them. Remember, we have our alpha and beta already, which are the two solutions possible from the general form of every quadratic equation. So I'm going to say right here, alpha plus beta equals, I'm going to add them right now, okay? So the first one for the alpha is negative b, then plus the square root of b squared minus 4ac, then this is all over 2a, and then plus, okay, I'm going to add the two of them. The next one is for the beta, which is minus b minus the square root of b squared minus 4ac all over 2a. Now we have two fractions. What do we do in this case? We can see that they both have the same denominator, 2a, 2a. Okay? So we have 2a here, we have 2a here. Since they have a common denominator, we don't have to bother about getting a common denominator for the two. Therefore, we just pick one. And hence, we're going to have alpha plus beta equals, we have negative b plus the square root of b squared minus 4ac. Then the next one here we have minus, okay, because this plus multiplied by this minus gives us a minus. So we can just go ahead and write a minus instead of writing plus and then a negative again. I hope you understand. So here we now have minus b, then minus, we have b squared minus 4ac all over the common denominator right now, which is 2a. Now let's proceed. We can go ahead and collect like terms in this case. Right here we have negative b and we have negative b. So negative b, or let me rearrange them. We can rearrange them for simplicity's sake. Right here we have alpha plus beta equals, I'm going to pick the negative b's first. So we have negative b, and what is remaining? We have plus the square root of b squared minus 4ac, and then the next one is minus b squared minus 4ac, and then all over 2a. Please follow me closely as we solve this very problem. Now, next up, you can see right here that here we have a positive root. We can see plus b squared minus 4ac, and we can see minus b squared minus 4ac. So This one here is a plus, this one is a minus. Just like when you have plus x minus x, it gives you what? 0, right? Correct. Now, in the same way, we are also going to do the same thing here. So this one is a plus, this is a minus. We can cancel them out, okay? So, and now we are going to be left with alpha plus beta equals minus b is minus 2b, and what is left at the denominator is 2a. Now, look at this here. 2 can divide 2, right? Correct. So when 2 on top divides the 1 at the denominator, we are now left with, we have that alpha plus beta equals negative b over a. So this is the first proof. Look at it here. I cancelled out these two. One is a plus, one is a minus. Just like when you have x minus x, it gives you a 0, and we're left with negative b. And negative b gives you negative 2b, okay, over 2a. Now, let's say 2 divided by 2, okay, that goes away, and we're now left with negative b on top over a. You can see it here, and this is the first solution. Now, let's go ahead and prove the second one, that alpha times beta equals c over a. So let's go ahead to show that alpha times beta equals c over a. Now, how do we do this? We're also going to remember that we wrote initially that alpha equals the positive root, which is negative b plus b squared minus 4ac all over 2a, while beta is the negative one, which is negative b minus, and we have b squared minus 4ac all over 2a. So they say we should prove that alpha times beta equals c over a. And that means that we are going to multiply them right now and see what we shall obtain. So let's do the multiplication. We have alpha times beta equals, let me multiply them. Right here we have, for the alpha, negative b, okay, then plus the square root of b squared minus 4ac. So this is going to multiply our beta, which is negative b negative. We have the square root of b squared minus 4ac. Okay, and this one has a denominator of 2a, while this one also has a denominator of 2a. So we have to go ahead and multiply them. Okay, let me extend this. Yeah, that's better. Okay. So we are multiplying the two of them. So let's begin with their denominators to make it simple. So 2a times 2a, since there are two fractions, right? You multiply top for top and bottom for bottom, or numerator for numerator, denominator for denominator. Let's do that. We have that alpha times beta equals, I'm still going to maintain the numerators as they are while I multiply the denominators. Here we have negative b plus the square root of b squared minus 4ac, and then this is multiplying the beta, which is negative b negative, and we have b squared minus 4ac. Okay, now when you multiply the two denominators, 2 times 2 gives you a 4. A times a is a squared. Negative b times negative b gives us a b squared. Then negative times negative gives us a plus. And next up, b times the square root of this will give us b multiplied by the square root of b squared minus 4ac. Then we're done with the first negative b. So let's go ahead and do the next one. So this plus the square root of b squared minus 4ac multiplied by negative b would give us negative b, then multiplied by the square root of b squared minus 4ac. Then we can close the bracket here. Okay, and then next up, right here we have the square root of b squared minus 4ac times negative the square root of b squared minus 4ac would give us minus. Since they are the same, we can just square them, right? So this one inside the square root and this inside the square root, they are the same. So since they are the same, one is a minus, or let's say plus times minus gives us a minus. And then since they are the same, we can just square them. And this gives us the square root of b squared minus 4ac, and this is 4 squared. Okay, so having gotten to this very point, we can now put our denominator, which is 4a squared. Correct. Now let's continue with the solution. Right here, we have b squared. We have b squared here. And when we look closely here, we'll discover that we have, this is a plus b, okay? This is a plus b multiplied by the square root of b squared minus 4ac. And this is a minus b, okay? This one is a plus b, this one is a minus b. They are like terms, okay? Because everything inside the square root are the same on both sides. It's the same for this and the same for that. So since they are the same, we can just cancel them out. One is a plus, one is a minus, we cancel them out. And next up, for the remainder here, we have a square on top of a square. So this square, we cancel out with this square, all right? And we're now left with minus, open bracket, b squared minus 4ac, and then this is all over 4a squared. Next up, we have to distribute the negative across everything inside the bracket. We have b squared. Now, negative times b squared gives us minus b squared. And then negative times the negative gives us plus 4ac all over 4a squared. Correct. Now, b squared minus b squared equals 0. Since they are like terms, equals 0. And we are left with 4ac over 4a squared. Now, this 4 on top cancels out with the 4 down here, and we're left with ac over a squared. Remember that we're doing for the product, and we've arrived at this point, so we say alpha times beta equals ac over a squared. Now, this a and one of the a's down here can cancel out, and we now have c over a remaining. And as a result, we have proven that alpha times beta, or the product of the roots, is given by the formula c over a. So this is a proof. We have successfully proven the sum and the product to be negative b over a and c over a. If you have any questions, concerns, or comments, you can reach out to me in the comment section, and I'll be right there waiting for you. Thank you, and bye.